Welcome to lesson 148 of Algebraic Concepts, Mixed Expressions and Complex Fractions. So what is this lesson about? Here's our objective, and here is our vocabulary. So please pause the video and read through this to catch up. And we've been seeing rational expressions for 7 lessons now, so we should be pretty familiar. And if you have not watched any of the previous videos, they start at lesson 2142. So please go back and watch one of the earlier videos, because once I get to 2144 or 45, I stop talking about excluded values. So please help yourself with that so you can understand what an excluded value is. All right, so basically, what is a mixed expression and a complex fraction? It's just a fraction inside of a fraction. That's all it is. So this is what we're going to be dealing with today, and, well, not today, but in this lesson. Okay, so let's look at our first example here. We got 3a plus a plus 2 over a minus 3. So the first thing we have to do is make 3a into a fraction by putting it over 1. A second thing we have to do is find a common denominator. Well, luckily, since this is 1, a minus 3 is our common denominator. So we just multiply top and bottom by a minus 3. And I'm going to rewrite that over here. So 3a times the quantity a minus 3 plus a plus 2 all over a minus 3. And so now I have to distribute the 3a, which gives me 3a squared minus 9a plus a plus 2 all over a minus 3. Combining terms, I get 3a squared minus 8a plus 2 all over a minus 3. So let's see, can I separate that top trinomial? Let's see, 2 negatives give a positive, so I get 3a minus 2 a plus 1. 3a minus 2a. Nope, that doesn't work. I don't think there's any factors of 2 that will give it. All right, so I can't put a 3 back there because 3 has no factors but 1 and 3. I don't think this polynomial is factorable. So I would leave it like that. Now, if you get on a standardized test and you see something like this and you solve it, if you get to this step and you're not sure, oops, that's supposed to be 3. I'm about to 3. That's supposed to be a 3. If you get here and your answers look different than what you have, I will go ahead and do the quadratic formula where x or a or whatever equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I will go ahead and use that, see if you can factor this trinomial, but I don't think you're going to get whole numbers. So let's try it. A negative of negative 8 plus or minus the square root b squared. Negative 8 squared minus 4 times 3 times 2 all over 2 times 3. I get negative of negative 8 is 8 plus or minus the square root of 64 minus 4 times 3 is 12, 24 all over 6. 8 plus or minus the square root of 40. This 40 is not a perfect square, so you won't get an integer out of it. You'll get a real number. So we're not even going to mess around with that. This is simplified. So sometimes you may have to do some extra work, but in this case, I mean, you could simplify the radical. I think I showed you how to simplify radicals somewhere in numbers and operations, but I'm not going to do that now because it's just not important to these problems. So this is as simple as you can get with this problem. Okay, let's look at our second example where you got a fraction on top of a fraction. Remember, this is a fraction bar, this is a fraction bar, and this is a fraction bar. It means divide. So the first thing I think to do when I see two fractions like this is I am going to separate them in a 21x squared over 25 divided by, so I took the middle fraction bar and changed it to this, 7x over 50. And then we know we have to change and flip. So 21x squared over 25 times 50 over 7x. That cancels out. That becomes 1. That becomes 2. That becomes 1. That becomes 3. 3 times 2 is 6x squared over x. That cancels out, and you're left with 6x. And that is how you do that one. Okay, so let's look at our third example. It looks crazy, but do not be worried. What I'm going to do is separate the top in red. I'm going to do the top in red, and I'm going to do the bottom in blue. I'm going to do these as two separate things because the division bar separates these two expressions into two different groups. So I'm going to solve them separately, and then I'll bring them back together. So let's start with the top. So you have y minus 1. We'll put it over 1 plus 3 over y plus 3. To get the same denominator, all you have to do is multiply this by y plus 3 over y plus 3. So we get y plus 3 over y plus 3, and then times y minus 1 plus 3 over y plus 3. And look at that. Okay, so now what are we going to do? We are going to FOIL this term right here. So you get y squared plus 3y minus 1y is plus 2y minus 3 plus 3 all over y plus 3, which gives us y squared plus 2y over y plus 3. And we can pull out a y, and we'll get y times y plus 2 over y plus 3. Sorry that got a little small. I'm running out of space, and that's a problem I always run into being left-handed. All right, so the top simplified is y times the quantity y plus 2 all over y plus 3. Okay, so now that's the top. Let's deal with the bottom. You get y plus 1, you put it over 1, minus 4 over y minus 2. Or y minus 2 is our same bottom. So you get y minus 2 times y plus 1 over y minus 2 minus 4 over y minus 2. We do the same thing we did in the other problem. You get y squared minus 2y plus 1y minus y minus 2 minus 4 all over y minus 2, which gives us y squared minus y minus 6 over y minus 2. And let's see, 3 and 2. Does 3 and 2 work? This becomes y minus 3, y plus 2 over y minus 2. So now we have to put the top and bottom together, because the red is the top and the blue is the bottom. I'm going to take this on another page. Okay, so what we have is y times the quantity of y plus 2 over y plus 3, and then that fraction divided by our next fraction, y minus 3 times y plus 2. The quantity of y minus 3 times the quantity of y plus 2 divided by y minus 2. Okay, so now treat these like fractions like we did in the previous problem. So y times y plus 2 over y plus 3 divided by y minus 3 y plus 2 over y minus 2, and then we get y times y plus 2 change flip over y plus 3 times y minus 2 over y minus 3 y plus 2. This cancels out, that cancels out. You get y times y minus 2 all over y plus 3 y minus 3, which is a difference of squares, which I could leave like this, or I could combine and do y squared minus 2y over y squared minus 9. So this may be the most common, but you may see it this way on some tests. So there you go. It looked harder than it was, but it wasn't really that hard. And I know that we're strong and resilient and we can do it. Okay, so those were our 3 examples. Please try to practice problems, and I will see you at the end of the video. Okay, so let's see what you did and how you did. All right, so first thing we got to do is put x minus 5 over 1. Our common denominator is x minus 2. So we multiply that there, multiply that there. So we get x minus 2 times x minus 5 plus x minus 4 all over x minus 2. Okay, let's do a little combination here. So x squared minus 2x minus 5x plus 10 minus 2x minus 3 is minus 7x. The factors 2 and 5. Okay. Plus x minus 4 over x minus 2. Combine like terms, you get x squared minus 6x plus 6 over x minus 2. There are no factors of 6 that add to 6. 1 and 6 add to 7. So this trinomial on the top is not factorable. So this is the simplified form. This is all you can do with this. Can't do anything else. Okay, here's our second problem. There's not much to do in the numerator, so leave that alone. And we're going to make the bottom x minus 5 over 5 because 1 is 5/5. So x minus 5 over 5 is the bottom. So we take x minus 5 over x, divide that by x minus 5 over 5. Oh, look at this. X minus 5 over x times flip, change, and flip 5 over x minus 5. The x minus 5's cancel out. We're left with 5 over x. Boom. Easy breezy, lemon squeezy. So I hope you got that one. It just looked harder. These look harder than they are. You just had to take your time and be persistent and just work through your fraction rules. All right, so let's look at our third problem. So let's deal with the, we got b squared minus 4 over 4 divided by, okay, so how do we make the bottoms the same? We multiply this one by 2 over 2. So you got b minus 2 over 4 over b minus 2 over 4. So you get b squared over 4 is a perfect square trinomial. You get b plus 2, b minus 2 over 4 divided by b minus 2 over 4. And you know what's going to happen. So get b plus 2, b minus 2 over 4 times 4 over b minus 2. B minus 2's cancel out, the 4's cancel out, and you're just left with b plus 2. And there you go. It looked harder than it was, but we did our fraction magic and we remembered these things. So when you get to this in Algebra 1, please do not be nervous. They look harder than they are, but they are not that difficult. Just be patient and stay with it, and you'll figure something out. Thank you for watching this video, and I hope to see you on the next video. So there are 2 more lessons dealing with rational equations. So that makes a series of 9.